Login accepted.
And I guess we're live. Hello, Devoxxans. How are you doing? How was the lunch? Good. Very nice. Did you take time to rest a little bit after the first half of the day? And there are like 5 more halves to go, right? Yes, kind of like a big event. It's great that we have these events back. So, welcome to this session, Hunting with Stream Gatherers, right? So, just briefly to introduce myself, I'm Piotr Przybył. You can find me on various social media. I work as a senior developer advocate for Elastic. For that reason, I won't be giving any stickers or other swags today during the talk because you can go and visit our booth. Actually, we have a booth today. So for like stickers, like some questions you might have and whatnot. I'm also Java champion, this containers champion, and whenever I have time and something interesting to write, I place it sometimes on softwaregarden.dev, which is my private blog page. Question is, who are you? Who's Java developer? Nice. Who's not Java developer? Kotliners, don't be shy. Okay, I'd say majority is like Java people. Okay, right, so obviously the next question has to be which Java version you have in production. Java 22? Okay, maybe Java 23 early access. Heinz, are you here? Okay, Heinz is not here. Java 21? Nice. 17? Nice. 11? Okay, 8? Still some folks. Okay, question. Who's not using streams in their production code? Lovely. Nobody. Cool. I mean, which means everybody is like at least somewhat familiar with streams. I'm pleased to meet you. Little warning for today. First, when I'm stressed, I can say funny things, meaning I can replace words with some other words, right? Basically, this is what happens sometimes. The other thing is, what I'll be showing you today is still in preview, right? This is a preview feature of Java 22 and 23, which means it can be changed, it can be altered, it can be even withdrawn as the string templates have taught us, right? So, for example, this feature might not be there in Java 24, for example. Yes, and it's a human thing to make a mistake, right? So I'm also like a human, so I reserve myself this right. Normally, I don't do agenda. I think like instead of like talking about what you'll be talking, it's better to go directly and talk about it, right? But like I think agenda might be nice for today. So here it is. There will be a prologue, 3 parts: the why, the what, and the how, and a little follow-up. Okay. So here's the prologue. Do you know what happened 3,746 days ago? Java 8, exactly. You want jellies. Yes, it was Java 8 what happened. And with Java 8, we had lambdas, right, which benefited from invoke dynamic, which was introduced in Java 7 and whatnot. So this is not the thing that happened instantly on the spot. And because of lambdas, which are nice, for example, not only as functional interfaces, right, but also they can be nicely used in streams, right? So we had streams in Java 8, or since Java 8, should I say. And what is a stream, right? A quick recap. So stream usually has a source, right? So we have to construct this stream somehow using, originating from a collection, an array, a split iterator, or whatever. Then we have a chain or any number of intermediate operations, right? And then we have terminal operations. So finally, we have this thing on hand, right? And like a difference between, for example, reactive streams is that the Java streams used for processing data are actually pool-based, right? So you can construct the whole stream, but no processing is done until you call this terminal operation, and it will sort of like start or initiate the whole processing. And streams are nice because they enable us, I mean, as long as you obey some simple rules, for example, that these intermediate operations, they don't rely on any external state, they don't mutate things, basically, so you kind of like go the proper functional way, right? You have nice declarative way of processing your data. And here are the, I mean, maybe there are even some more operations, right? So of course, the two kings, which are filter and map. I sincerely hope you weren't using pick, at least not in production, maybe like for some like debugging, right? We have, of course, parallel when we try to do more things at the same time, like we have limit and skip when we wanted to have like a skip, like, I don't know, first 5 elements, or limit ourselves to 10 elements, and so on. Thing is, I mean, when I was doing training sessions for streams, like tell people how to switch gears, how to change their mindset, right, migrating to this new Java 8+ way of processing data, actually it's quite useful to go this declarative way, or like even translate snippets written in SQL to Java code, because this is how we can think about this stuff, right? And there are, of course, some terminal operations. I mean, in theory, we could go with just one, for example, reduce or collect, but they are here just for our convenience, so there are more ways to get something out of this stream, right? And that was Java 8, and turned out that we needed more stuff. For example, in Java 9, we had take while and drop while. So we had a predicate, right, and condition to satisfy, and then we were dropping or taking elements as long as something was true. In Java 16, we had a few more operations, right, for mapping. We also had some more terminal operations. In Java 16, we had toList, right? And I guess there are still like some heated debates whether it's a fortunate name, whether we need it or not. I mean, we had the collectors after all. We could go to list, to immutable list, whatever you need, and so on, right? And then there were actually like more operations, like terminal operations, because we had these two collectors, filtering and flat mapping in Java 9. Or in Java 12, we had team collector, right? So if you want to collect two things at the same time, you can just use team collector. Or in what actually happened in the ecosystem, it was the libraries that were like collectors should you need like collectors which don't exist in the standard library, or collectors, for example, that use like or are like better parallelizable because they use like a different thread pool, and so on and so on. So for example, we had parallel collectors from Pivot and his friends. And of course, I mean, don't lie to me, I know that in your company, in your little pet projects, you have this utils package or utils class, and probably, I mean, chances are that you have your own collectors in there, right? So why do we have this talk, right? Or why do we think that there might be still something that can be perhaps added to streams in Java? Better said, we might have some problems, right, around stream processing in Java. So who doesn't speak Polish? Okay, so you don't know this. I mean, even if you speak Polish, you might not know it. So basically, this is a count out, right? So when there's like a group of children, and you need to like count out who's like, for example, like going to be the I mean, like do something in the following day or something. So in English, for example, you have ini, mini, mini, mo, right? So this is what we can have in Polish. I was even told it originates from this very city, from Kraków, ene, due, rike, fake, and so on. And this is going to be our stream of strings we're going to use for these examples, okay? And now, for example, we are facing this task. So out of this stream, I mean, we're going to divide these words into like individual, or this string into individual words, right? If you're wondering, by the way, what the heck is this? This is string, how's it called? Text block, right? Since Java 15, if I'm not mistaken, right? So you can declare like a big string like this. Because of this backslash, I don't have like a new lines, so I can just split it by space, right? And then I have this stream of these like individual words, and I want to have a set of words, and so that in this set, each length existing here in this little example is represented by one word. For example, so if I have ene, I don't want to have due, or when I have due, I don't want to have ene. I don't care about like what word exactly it is. I just want to have exactly one word, or max one word, which is the length of 3. Okay? And the thing is, how do we do that using streams in Java? And this is one of the solutions. There are many ways you can solve this, basically. And this is one of the approaches, right? So we can create this stream, and then we can collect, right? We can go for collecting and we can use these collectors to map. Actually, maybe I can even go and show you that in actual code, right? Wouldn't code be better? With collector, with collect, yes, that should be it. Let me try to run this thing. Yes, so this is the results. Because I have ene, I don't want to have due, right? And this is how it works, for example. So first, why I'm using collecting and then? Because I'm collecting them to basically, this is the the finisher, right? Which I'm gonna use. So I'm first putting them in a map, but because I need to have a set, not a map, just 1, E or 3, and I just want to have, it's pictures time, sorry. Okay, we can continue. Sorry, take a break. People, you put your hands together, you clap a lot, you basically do bravos for all the speakers, organizers, and stuff like this. Nobody gives applause for people who operate the screens, the microphone, or takes pictures. Like, take a big bravo for them. Thank you very much. Yes. So this is what happens, right? Here I'm mapping these words, or I'm putting them into this map, right? So I'm dividing them by the length, and for the word I'm going to have word, right? So these are the key mapper, value mapper, and I'm going to have merge functions. So basically I ignore the subsequent things, right? This is also what came with like in a recent Java version, so we can use underscore to mark that you're skipping something. And then because of this hash map, I'm going to extract from this hash map basically a hash set that's going to have, or from this map, sorry, just the values, right? So I get this set of these values. If I need to reuse this collector in other places, instead of creating it in C2 in this single place, what I can do is basically I can create a collector, right? And this collector looks like this. So I have the initial state, right, or supply for initial state. Then I need to tell what happens if I have this map and the word, right? So I put it if absent, right, by the length of the word, for example. How can I merge two maps if I'm running a parallel stream, right? And then this the finisher. So what's the last step? After I've processed all the elements, right? So then maybe this way is sort of like a more suitable for you. So I can go for this collector off, or I can even implement my own collector, right? And this is how you can basically take the last operation, this terminal operation, and turn it into something you can actually have, right? Return from a method or have like an object or whatever. The thing is, what happens if we need to lowercase the words from this set? All right? This is like, for example, when I have this result here, see, ene starts with uppercase, right? And I want it, for example, all lowercase. So what I can do is, for example, something like this, right? I can go of course, see, let's say go for this collecting and then I collected the set of these unique by length words, right? Just like in the previous step, using this collector from here. See, this is this method, right? and then I have to say, and then do something, do some post-processing. So what I'm doing here, basically, I'm out of this set creating again a stream, which is totally new stream, right? And I can go string to uppercase, which means, by the way, that I didn't read the requirements because they said lowercase, and I'm going uppercase, but who cares, right? And then I'm going to go collectors to set again, right? So basically, I had stream, and then I have a stream, which kind of like gives us a clue that this might be somewhat wasteful. Or, yeah, this is not perfect solution because we have another stream. Maybe we can like use and map all the elements like before we collect, but then we're gonna map them all, right? So we're gonna lowercase them all, even if we're gonna skip them from the collection phase or in the collection phase. So in a way, it's wasteful, right? We're processing elements we don't need. Or maybe we could decorate these elements, right? So then we can use stream.distinct. Distinct in stream is using the equals method. So basically, we would need to wrap our streams into like some kind of other type, be that record, for example, and then we would need to write equals and hash code there. So for example, wrappers of two strings, even totally different strings, but having the same length would give us true for equals, right? Or we can have another pro and fancy solution just to go around this and use the API we have more or less in like between Java 8 and Java 21, right? Or we can go to the OpenJDK issue tracker and say, please add stream.distinct by, so then I can have, for example, like, I don't know, some interface, like use a function, a lambda, whatever, so I can say that these elements are distinct in a different way than by just using equals, okay? And this is actually what happened. People went and said like we want distinct by, we want like other methods. Basically, everyone like was going for this approach like with take while and drop while, right? And OpenJDK maintainers could have added this distinct by, or they could have also added dozens of other methods that were requested by people. Hey, this is my legitimate business case. I have this set of data. I need to process it this way, and it's impossible. I mean, or it's possible, but the solution is clumsy. So could you please have this yet another method for me, right, in the whole stream API? And the thing is, if OpenJDK maintainers were sort of like, yes, let's have this, right, people, then we would have like stream API really, really bloated, because there is like a few people in the world who have this really legitimate need for something, right? But then it's going to be like not needed by 99.987% of people, or like just Java users, right? So how to find the balance, right? And then it's like we started wondering if only there was something that we could use, right? Something working as collectors, but only in the middle of the stream, not at the end of the stream, right? What could that be? And here we go to part 2, the what. And the what is going to be something like a plugin, right? So we have a plugin. You basically plug it in the whole stream processing pipeline, right? And we are familiar in the concept of plugins, right? They are like design patterns. You can have them in the browser, in whatever. You just have like something has to be compatible. Yeah, you have a socket and a plug. You plug it in, it works, right? In general. Nothing fancy. So we have stream gatherers. As I told you, they are a preview feature in Java 22 and 23. As far as I can tell, there is no API difference between these two. I encourage you to go and study at least one of them, right? And of course, like I'll continue doing this in this talk. A little Polish detour. Sorry, I really had to, because we are like in the capital of Poland, right? So, thank you. And here we go back to the cover image, which I generated using, of course, like OpenAI. I mean, I paid $20, so at least I have to use it for something, right? So if you go to this article in Wikipedia, Społeczeństwo zbieracko-łowieckie, when you try to translate it to or see the English version, it will show you that you want to have something like hunter-gatherer, right? So basically, as humankind, before we became farmers, right, settled farmers, we went hunters and gatherers, right? That's why I think that hunters, and it should be translated to Polish as zbieracze. Sorry, not hunters, gatherers, of course. gatherers, right? Should be translated to something as zbieracze, but then we have a problem going back from there. So when we go for the dictionary and when we check, for example, what zbieracz is, like in here, and this is one of the issues I have in general with these JEPs, right? I imagine Polish is not unique in this regard, because zbieracz could be translated as fun fact collector or gatherer. So yeah, as you can imagine, it can be somewhat confusing, right? I appreciate your laughter, sir. Yes, but basically, that's the thing. Yeah. So also, please don't hallucinate. I went and asked, because I paid $20, right? I went and asked like this newest GPT thingy, what are stream gatherers in Java, right? And it gave me the answer. It started like hallucinating something about collectors and that you can go stream collect and something. So see, semantically, these ideas are close, right? And by the way, I use this example in other talks of mine when I'm trying to tell you how you should enhance this. For example, I'm sending just the JEP document to ChatGPT, and then it gives you correct answer, right, about stream gatherers. Anyway, too long, didn't read. This is it, okay? We now have a new intermediate operation called gather, and then as A, B, or C, we put a gatherer, right? And then we can call collect, for example, or I don't know, reduce, or whatever have you, right? And you can have any number of them, or you can stack them or compose them like this. So you either go gather, 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 or you can go gather and then you go back to collect. Up to you, whatever you choose. Right. So what these stream gatherers can in general, so they can transform elements and they can transform them one-to-one. Like map is doing, right? They can translate one to many, right? So, and then as many, I don't mean that from one element you get the one list of something. It's just from one element you will get, like, for example, 2 or 7 elements or 0 elements, because they can be skipped. Many elements can be merged into one element, or like any number of elements can be turned into any other arbitrary number of elements. Actually, I should have like M and N here in this example. Sorry, it shouldn't be, because this suggests it's the same number. These are 2 different numbers, okay? String gatherers can also track the previous elements, right, in map or in filter, unless you apply like some other store, like an accumulator or a state where you have on the side. You don't know this. Gatherers can know this by design, okay? They can also suspend the elements. So for example, they can take 1, 2, 3 and then release all 3 at once, for example. They can short circuit in infinite streams into limited or finite streams. Okay, that's also doable. What they can do, they can, even if you please, so if you create an object of a gatherer, they can keep state between executions, right, or processing of streams. I don't know if it's a good practice, but in theory, it's doable, right? And they can also enable, of course, parallel execution. So now we go to part 3. Okay, the how. So let's try to tackle the same task again, okay? So now I can express it like this. Maybe let me go to code again. Yes, like this, just with gatherer, with single gatherer, right? So I'm creating a gatherer here, like this, or maybe this example would be better, right? Sorry, this one. So I have the stream, and then I say gather using this gatherer, right? And then I can see it's not a terminal operation, it's intermediate operation. So I'm still going to operate on strings, right? So I can say to uppercase, and then I collect them to unmodifiable set. So when you take a look at this, the intention standing between this pipeline is, I believe, much, much clearer, right? I mean, both examples are, let's say, on par, like you eventually you get the same set or set of the same elements, but how you write this, and especially how you read it 2 weeks later or 2 years later, is fundamentally different, right? And we can go for this gatherer, right, and examine it. And for example, when I create it like this is how it looks like, right? So I'm putting an integrator here. So if I have state, the element I'm going to process, and the downstream, so things I'm going to ship down the pipeline, right? And if my current state, and this is my state because I initialize it to be as a hash set, right? So see, I can track the elements I already processed in my stream, right? So if this state already contains this element, or sorry, doesn't contain this element, then I'm going to add it to my state just by the length, right? Because I don't keep the words, I just keep the lengths of the words that I already pushed down the stream, okay? And then if I didn't push, let's say I have element of length 3, I didn't push element of length 3, then I'm going to add it like, okay, I'm pushing 3, and here it's pushed, right? And then I return true, which means give me more, okay? And this is an integrator, which is like the key component of a gatherer. Or what we can do is like we can create a gatherer pretty much like we created a collector on Spot. So what I can say is like this is my how I initialize. This is the supplier to initialize my state, the internal state I'm going to keep, right? And this is the integrator. Integrator, I would say, is the key component or the engine of a gatherer. It's the mandatory part. Every other part is optional. This part is mandatory. And this is, again, the same thing. It's just a lambda, right? So if I have state, element, and downstream, it's doing exactly the same thing, right? And then when I run it, let's be sure that I actually run it, right? So I'm not cheating. See, this is like, I get the same results, right? I get the same results. It's just my code is much, much cleaner, I would say. So the formal definition of a stream gatherer is like this. If you extract it from a gatherer, there are like a few more things, but this is like if I'm not mistaken, this is like the key part. By the way, take a look that this is not green because JavaScript plugin has issues, I get, with types or something. Never mind. I don't quite like these definitions, and I'm really puzzled why are we so focused on this one character types. Isn't it better to read it sort of like this? So basically, a gatherer has 3 types. Type of its state, internal state, right? Type of the elements it's ingesting, and type of elements it's putting down the stream. And that's it, right? And the integrator, as you can see, has no default implementation, so it's a mandatory part, right? And we saw one, or just like maybe in 2. Then you have like supplier for the initial state. You have combiner of the state. The combiner is used in parallel gatherers if you have 2 gatherers at the end and you need to combine the state of theirs, right? Pretty much like in collectors. And then we also have finisher, which is by consumer because it has to have not just state, but also the downstream. So for example, in finisher, we can add some more extra elements, right? Yes. And we can construct these gatherers on site using a bunch of methods. So if you just have an integrator, you don't need a state. For example, you need just a mapper, right? An equivalent of stream.map. You can go like this, gatherer of sequential, and you put an integrator there, which, I remind you, can be basically a lambda, or you can put like an object here, whatever you please, right? We can also add finisher. We can also add initializer if we need them. If we need all 3 of them, no problem. Initializer, integrator, and finisher, right? We can't have combiner when it's sequential, right? Because it's sequential, so naturally there won't be like a parallel thing to combine or merge. So we can go for integrator like this with finisher, and then they're going to use default combiners, right? Or when we want to provide combiner directly, we can go for this like full size gatherer, right? Or of course we can do something like let's say public class implements gatherer, right? And you can implement it as an object, like I don't know, publish it as a library or whatever. And as I told you, the key component, the engine, the mandatory engine, is the integrator, right? And it actually has this method, which we saw as in a state of lambda. So it has the current state, so it can know, or it knows basically what was processed so far by this gatherer, what's this next element to process, and basically the downstream. So this is like the way to push the elements down the stream, right? I like the what was the name in English? Like a poo sticks in Winnie the Pooh, or in Polish misie patysie, right? So you're throwing a stick in a stream and it's flowing, right? So this is a downstream basically. So it consumes this next element, may inspect or update current state, right? That's why it's advisable this thing is mutable or modifiable, right? It can send any numbers, any items down the stream, right? So 0, 1, 17, whatever. It can return true, as I told you, which means give me more. I want to like process more elements, right? Or we can also have a greedy integrator, which is kind of like optimization, the way I understand it, which means it will never short circuit, which means it will always like, we have a contract that it will always return true, like give me more, like so it will consume all the elements, or gather all the elements, sorry, from the stream. We have a combiner, right, and it basically combines two parallelizable gatherers, and we have finisher, which can still operate on downstream. So, for example, if we, let's say, had gatherer of your email message, it could gather your email mail by mail by mail by mail, and then, sorry, line by line by line by line, and then at the very end, it could add, for example, your signature, if there are no more lines to gather, right? And the downstream, yes, to push things down the stream. We have some built-in gatherers already. As far as I can tell, there are 4. There's gatherers.fold, scan, window fixed, window sliding, and map concurrent. And this is how they work. Maybe let's go for the demo again, which should be here. Yes, so at least I have this sphere gatherers here, and let's see what they do. So they always do this the same. So I take 10 integers. All right, and I just fold them, and when I fold them, it's just like a fold in functional programming, right? If you may know, basically, so they were folded all into a single element, and the way I chose them to fold is basically to concatenate the number to existing stream, right? And so it is. We can also have scanning, so scanning is basically like prefixing. So see, in this way, right, I know what already happened. So when I'm processing 1, I know that I already processed 0 before it. When I'm processing 2, I know that 01 is the string I already had, and so on, right? I'm just keeping it this way. I have fixed window, so I have a window of the size 3. So for example, I want to turn my the elements into like, de facto these are just lists, right? So I'm creating a lists here, so list of size 3, so I have 3, 3, 3, and what's ever left, right? So this can be like 0, 1, 2, or 3 elements. 0 basically would mean, sorry, silly me, that there's nothing. So it can be 1, 2, or 3 elements in the last one. Or I can have sliding window. So I have 0, 1, 2 in the first, as a first element emitted. Then I have 1, 2, 3, and so on. So as you can see, this is the like relationship. So I can reduce the number of elements processed. I can keep the same number of elements, but then I keep the state of the previous ones, right? Or I can like reduce the number, or I can keep the same number, but then I'm adding like what happened before, and so on, right? So this is basically what stream gatherers can give us. And now we're heading to the epilogue, I say, and who's using streams in their production code? Cool. Who's using, keep your hands raised, please. Who's using streams in a critical path when the performance is absolutely crucial? Or who said, like, after benchmarking, okay, I mean, I'm sorry, I have to go for for loop because for loop is more efficient? And I see people like, yeah, okay, that was that case. Yes, exactly. Exactly that. So streams look nice, but when you need to process data, and it's not just like, let's say, init or something, then sometimes we need to sacrifice the readability, the nice declarative / functional style, right? And go like this pesky imperative for loops or whatever, but then we get like nice performance, right? Because the parallel streams do block, right? They do block. So for example, when I have, and again, like I have another talk when I'm butchering virtual threads, but this is like one of the examples from that other talk. Let's say we have a stream, right? I'm going to process 100 elements, like in here. I turn it into parallel stream, and then I'm going to do something like map them. For example, let's say I need to call an external system. This is an ID of an entity. I need to fetch the whole entity, right? From a document store, from a database, from, I don't know, like a microservice or whatever, and then I have to list them. So if I have 100 elements, right, and this takes 1 second, how many seconds this whole thing is gonna take? Come on, is it gonna take 1 second, 100 seconds, 50 seconds? It depends. Who said it depends? Very nice, you want jellies. Sorry, I'm better at throwing exceptions, sorry. Now, the question is, what does it depend on? And now everyone wants jellies, sorry, like I don't have that many. Yes, but it basically depends on 2 things. First, how many CPU cores I have. So based on this, there will be the size of the ForkJoin pool working under the hood in this parallel, right? And the second thing, if I'm using already parallel streams, aka this ForkJoin pool in some other places already. Meaning, if I go like this, I won't double my throughput, right? Because I still have the same number of threads / CPU cores, right? They sort of like pin to cores. And then if this is blocking and most importantly not releasing these threads here, right? Then I'm stuck. So maybe I can show that in code. Let me gather something like maybe not this, but this. Yes. So I have this slow to double, right? And I'm basically I mimic here that getting data from somewhere takes me 1 second, right? So I'm gonna say like which element I doubled already. All right. So when I run this thing using parallel stream, and for 100 elements, it's gonna take me, if I'm not mistaken, 7 seconds. Let's run this, and I say 7 seconds because I have 16 cores. I mean logical cores in, not 16, sorry, wrong machine. I have 12, right? So if I have 12, I'm running them in batches of 12. So 12, 24, and so on and so forth, right? So then eventually I'm reaching 96, right? After 8 seconds, I'm reaching 96, and then I have last remaining 4 processed in the 9th second. That's why I have 9 seconds, right? The thing is, do you know a thing in modern Java that is not blocking for I/O? Anyone? Who said virtual threads? Okay, 2 of you, very nice, because I have 2 last jellies. Okay, maybe I won't throw, maybe you'll come and collect them, okay? Come and gather them later. Thank you very much. Yes, virtual threads. And then we have this thing which, in my opinion, my personal subjective opinion, is the absolute gem of this Java 22. Like we have this hunter, right, or gatherer on this white horse, and it's holding this gem, right? And it's this gatherers.map concurrent. So I can put here the concurrency factor, and I can say, or use use here, this mapper function, right? I was so excited about it, I even wrote like a blog post on my page, right? So if you prefer reading to listening, this is it. So basically, we need something like this. So instead of going for in parallel stream.map, I'm going to just say gather using a gatherers.map concurrent, right? So where am I? So instead of parallel.map, what I'm going to do is this, gatherers map concurrent. So I'm going to say use up to 100 virtual threads, right? And use the very same method you see as before. And now, how long this whole thing is going to take? What do you think? 1 second. Sorry, no more jellies, but maybe you can get something at the booth. Yes, it takes more or less 1 second, right? Because, I mean, I used thread sleep. You shouldn't be using thread sleep in production code, okay? It's demo only, okay? But if this way I emulate that you're calling a third-party service, right? And instead of waiting, you just use virtual threads. And see, this is how nicely the features from Java, like every modern versions, are going there on and on and on. By the way, I'm not sure if anyone has noticed, I have public static void main, which doesn't have string arguments, right? Which is another, like a preview feature in modern Java. So actually, we don't even need, if I'm not mistaken, we don't even need this to run. Let's try to rerun it again. We can talk about this later, if it's evil or not. It depends. Yeah, shall I remove this class for you, Rene? Yeah. Okay, let's go wild then. Let's try if it goes like this. Sorry, I deleted too much. But if I go and delete this, I mean, since you asked for it, see, I even have no class, but then I cannot have package, right? So okay, it's another demo. Sorry. But as you can see, it's now complaining only about this package, right? So I can even remove the whole class. So as you can see, new Java is doing like a lot of exciting things, not just gatherers. Yes, so this is my opinion, the absolute killer. So using basically this gatherers.map concurrent, what we can do is sort of like bring streams back or stream API back to the critical points. And now I'm not trying to tell you that maybe this is something you should be using them for, like to enrich your stuff from external systems when you have like I/O, which is now not blocking because of virtual threads, but it gives you an idea what you can use it for. I have, since we have time, very nice. I have some other examples. Let's go for them. So, for example, one of the things I can show you is, do you know what an n-gram is? When you search for something and you just type 2 letters, even 2 letters in between or 3 letters, sometimes you get a drop box and it's suggesting you the right thing. Right? I'm not saying that when you search for something you should be using n-grams all the way, but sometimes it's like a very decent or nice use case. So basically, I can show you it right here. I'm just gonna make this call to Elasticsearch, right? So I'm gonna use this n-gram tokenizer. So when I have quick forks, right, I get Q, QU, and then I say have like U and so on. So basically, this is my result, right? And the question is now, can I easily somehow implement it using these stream gatherers? And the answer is yes. I mean, I hope you won't re-implement Elasticsearch, right? Because that could render me jobless. But I just give you an example how we could implement this default one, right? Which has like minimum 1 and maximum 2. So see, I'm gonna here to map the characters to just strings. Right? So I will create, out of each character, I'm going to create a string. And this is what I expect to have in return, right? And then I have this gatherer, which is sequential one. And what I have here, maybe I should have formatted it differently, sorry, like this. Yes, so I initialize my state. This could be an array, this could be a set, right? I don't know. I just decided to keep an array list, to keep things really, really simple, not necessarily efficient. But simple. And then if my state is empty, I add this element I'm processing to my state. So when I'm processing Q, for example, I'm going to add Q, right? And then I'm going to push Q down the stream. Okay? And then when I'm processing the next element, which means in my state I already have Q, right, I'm going to push downstream and see this is the beauty of stream gatherers. They are not bound, like I got one element and I have to send one element down. I can send 2 elements down. So the state plus my current element, so QU, I can then send my current element, which is U, and I can, from my state, basically like remove what I had and just put U in there. Okay, so let's try to run this. And I would say, okay, I just used like a new line, but this is what we expected, like, right? Q, QU, U, UI, and so on and so on and so on. And I would say when I take a look at such code, I mean, I didn't even optimize it. I didn't extract the new class or something, but you can already see that now we have like a new expressive way and also like much easier to read using these stream gatherers, right? Another examples I can show you is, let me just roll back this, sorry. Yeah, for example, how to look for, not this one, not you, for anomalies, right? So, of course, like good monitoring solution should be in place. But for example, you are interested in fluctuations of a length of something. And as a length, I mean, I have words now. So this, we are not processing ene, due, reke, fake, and so on. We have just different like list of words. And what I'm interested in, for example, if there is like a big difference, bigger than just one character between 2 consecutive ones. So for example, when I see noon and redder, you see the diff in length is 2 characters. So I want to know, for example, oops, the temperature raised, or suddenly I have a spike in requests, or whatever, right? So how we can use this this way is, let me try to run it now. Sorry, I'm not efficient with like a, like a Kifu, but we should have this. Yeah, noon redder is among the examples, and how it works is this. I am gathering the elements I have in this window sliding, right? So it's generating me like lists of 2 elements, first and second, second and third, third and fourth, and so on. And then what I basically do, I just compare the difference in length between the first and the last element in this list, right? And if it's bigger than 1, then I want to send it down the stream to do something about it, okay? So in this case, I'm just putting it to the console output. I've shown you concurrent mapping, right? And there should be also like, what's this purse thingy? Maybe you could decipher. Or let's try to run it. What was the, yes. Right, so what I can do here is I can turn, instead of like turning the elements using window fixed, for example, I can turn them on my own into pairs, right, of elements. So I have this, again, like this array list, and if it's empty, I'm just adding it to my state, and as you can see, in this case, I'm not emitting anything, so I'm sort of like suspending this element, right? And then when I get the other one, I can emit a new pair, which is the element I have accumulated, and the current one, and I can remove it from the stream. And so here I emit nothing, here I emit like a new element consisting of the 2 elements I previously collected, and so on. So you can now process the elements in streams, I would say, however we please. Okay. Now, I do this, I believe, at almost every talk, and I encourage you to do this at every talk, every conference, every meetup, every whatever, to always give your feedback to the organizers, to the speakers, right? So I believe on your badges, you should have like a QR code. I gave this talk for the very first time, so I would really appreciate if you could tell me if you think it was useful, what was okay, what wasn't okay, right? Just using this Devoxx app. Now, if you're watching this on YouTube, I believe you should do 2 things. First, hit the subscribe button, right? And the bell, they always say in the bell. The second, you can always, I mean, if you prefer this, of course, you can also like fill this survey. This is like my own survey. It's anonymous unless you introduce yourselves, like what you think was okay, what wasn't okay. I really appreciate your feedback, people. As I said, we are almost out of swag, but we should still have some stickers in our booth and so on. This is if you you have like an urge to follow me on social media due to whatever reason. These are the slides, and everything in this talk is behind this link. So if you need to take one picture from this presentation, it's the picture. In 4, 3, 2, 1. Thank you very much.